So, hey, welcome to Lesson 75, my Algebra 2 students. We're going to talk about some more sign changes for common denominators, but we're also going to talk about and add in the element of factoring a trinomial to get to one of those common denominators. So we've discussed how the addition of rational expressions can sometimes be helped along by making sign changes in one or more of the expressions. For example, this problem, 3x plus 2 over x minus 5 plus x minus 3, 5 minus x. Now we know that's not right. We know it's supposed to be negative x plus 5 because we want it in the same format so we can see it, right? They're just trying to mess us up. So we are just going to move this back up here where this goes. All right, so now that's what we have. But we need to be able to change the sign of all of this, so that it'll match this, so we have a common denominator, because that's the only thing that's different is the sign. So what we do is we multiply the top and the bottom by -1, right? So then we end up with 3x plus 2 over x minus 5. And then this is going to be plus negative x plus 3. And then this is x minus 5. Now they match, right? Now that's what we wanted. So now we can combine everything. 3x plus 2. We skip this because this already has its own sign. Minus x plus 3. And then this is all over x minus 5. When we combine all like terms, we get 2x plus 5 because that's a -1. You always have that invisible 1 right there. And then this becomes x minus 5 under the bottom, and then that would be the answer to that, right? So we remember how to do that. We just applied, we know that we can apply the same number to the top and the bottom. We can multiply, and the fraction's value remains the same. As long as we multiply the same number times the top and the same number times the bottom. We know this because we can say 1/4 plus 1/2. And we know we can just multiply the top and the bottom by 2. It's the same value. It just becomes 2 over 4. And then that's 3/4. We know we can do that. So that's all we're doing here by using a -1. It's the same principle that we learned in like 7th grade math. We're just using it in a little bit more complex fraction. That's all we're doing. It's the same thing. Okay, so let's clear the page and let's actually do an example problem. So this one's a little bit harder. As I said before, we have x plus 3, and then we have a trinomial x squared minus x minus 6, then this is minus 3, and then that is 3 minus x, right? So we know, of course, they're messing with us. We have to rewrite this. This is negative x plus 3, right? We're going to get rid of this, and we're going to move this in place because they're just messing with our head when they write it. They think they're tricking us, right? Like we're that silly that we would fall for that. So all we're going to do here is factor the trinomial. That's our first step, is to see what we have that we can have in common. So we're going to factor this out, and we know x squared is just x times x. And now we have to think about the factors of negative 6 right here that will equal, this is a 1, so -1. What are the factors of 6 that will equal -6 will equal -1? So right away, I'm thinking -3 and +2, and we combine those, we do get a -1, so that's correct. So this will be -3, and this will be +2. So right away, I see x and 3, x and 3. So I need to get this denominator to where it is the opposite signs. So I'm just going to multiply this one and this one, right? So now I have x plus 3, x minus 3, x plus 2, minus negative 3, and then x minus 3, right? Right. Okay, so now because this is a negative and this is a negative, I can change that. A negative times a negative, that's going to be, because this is a -1, and we always apply this negative sign to the numerator, not the denominator. These two will cancel out, so I can just erase this and make that a positive. All right, do you follow? Okay, so we see how that works. We have a negative times a negative, it makes it a positive. So this is our new formatted or equated or related, however you want to say that. This is our new form of this up here that we started with. But now we have something that's common between the two of them. But we also see we have another element in this denominator. So how do we make these two have the same common denominator? We take this bit that's missing from this side and we multiply it. So we put x plus 2 up here times x plus 2 down here, right? Guess what? That's really all we have to do to get that to be the same. But we're going to go ahead and distribute just for the sake of having like terms. So we have x plus 3, and then we have 3 times x, so it's going to be plus 3x, and then 3 times 2 is going to be plus 6, and that's all over x minus 3, x plus 2. And when we combine like terms, that's going to be, this is a 1x, so 1x plus 3x is 4x. We have 3 and 6 plus 9 over x minus 3, x plus 2. Now, is that as far as we can go? It is. Now, we could redistribute that if we wanted to, and we could just say that this is 4x plus 9. We could do that over our original, which is x squared minus x minus 6. So this is our final answer right there. You can stop there. I don't have a problem with that, but you can take it all the way out too. I don't have a problem with that either. So either one of these, I'll have those both set up as answers, and whenever we get to a pod that, well, in this pod, I suppose, I'm thinking ahead. All right, so let's do one more. Let's get some more practice in. So I'm gonna clear this page. Remember to pause when you need to so that you can write it down. Let's do x plus 7 over x squared plus 2x plus 1. Now remember, girls, if you ever get to the point to where you are waiting for me to put pods out there, you can always pull up the textbook from your material section and read ahead. You can absolutely do that. You don't have to wait for me. You do, but we have a pace, right? If you get to the end and I haven't put out Monday's work and it's Friday and you just want to do some math homework, feel free to open up the book and read Monday's lesson. All right. Okay. I'm just putting that out there because I know that there are certain ones of you who are asking me for more work. There you go. It's already in the material section. Merry Christmas. That's my gift to you. All right, so right away, we know that this one is backwards. We're going to fix it, -x, and this is -1. Right. What do you want to bet that there is x plus 1 over here somewhere? I'm pretty willing to bet that. So let's factor this. X plus 7 minus 3 minus x minus 1, right? So we're going to factor this. And we need to have the factors of positive 1 that give us 2. Oh, I don't know. How about 1 times 1? That looks right to me. X plus 1 plus 1. Oh, well, how about that? We have x plus 1 squared. So this has all got to change. So we're just going to multiply negative x plus 7 over x plus 1 times x plus 1. This becomes a positive 3, and these become positive x plus 1. So now we just need to take another x plus 1 and multiply. Make sure it's the whole thing times the whole thing. You don't want to, if you forget the parenthesis, then it's not the whole thing times the whole thing. It's just 1 times this. So don't forget your parenthesis. That's important. It actually does mean something. So when we redistribute this, I'm going to put this up here, right? I'm going to go up here with that. X plus 7 over x plus 1. And I'm just going to say that squared for the sake of space. That is going to be plus 3x plus 3 over x plus 1 squared. All right, so then let's combine that into 1, and we have 4x plus 10. And if you wanted to, you could go back and take it to its original form, x squared plus 2x plus 1. And that would be the final answer. Voila. All right, 75.3. These aren't so hard. I mean, look, 1, 2, 3, 4, 5 steps. 5 steps is not so bad. Let's clear the page. Let's look at 75.3. So we have x minus 3 over x squared minus 2x minus 15 plus, oh, this one's a little bit harder. This is a little thingy like that. And then x minus 5. Oh, this one's actually in the right format. Well, isn't that nice of them? So let's go ahead and factor. X minus 3. We need the factors of negative 15. That equals negative 2. So I'm thinking negative 5 and positive 3. That times that gives us negative 15. And it also gives us negative 2. So that's what we're going to use. X minus 5. X plus 3. And look at that. We don't even have to do anything. We don't even have to do anything. How cool is that? Right? Nice. It's already x minus 5. So all we really have to do is take the x plus 2, the x plus 3 up here. So we've already got the x minus 5 down here, right? So we're just going to say x minus 3 plus, this is going to be x squared plus 3x plus 2x plus 6. And then we can just put that over our original x squared. Actually, no, we're not. You know what we're going to do? We're going to just leave this because I think I know what's going to happen. I think we're going to factor some things out. So let's see if we can do that. All right, let me move this over. I don't know why I took up so much stinking room with this. Put this back over here. All right, so let's combine like terms. So I have an x squared. Let's do it in descending order. X squared. And then I have a 1x positive. That's 4x. That's 6x. So plus 6x. And then I have a negative 3 and a positive 6, so that's going to be a positive 3. Okay. And now I have an x minus 5 and an x plus 3 on the bottom. And that's not the same answer that the book has. So I wonder what I did differently. I wonder if I wrote it down the wrong way. Let's see. No. I think the book made a mistake, guys. I'm looking at the book. All right, I want to show you what I am seeing. So, let me see if I can pull it up. Fun stuff. Okay. If you see where I made a mistake, please let me know. But I can't see how. Okay, where is it at? Let's find, here we are, lesson 75. It's probably going to take a million years for it to open. Come on. Okay, here we go. So look, here's what I'm seeing. I want you to see the same thing so that I'm not completely crazy. Let's see if you guys see it. So here's what I'm looking at, right? This is what's in the book, x minus 5. And then when we factor this, we get x minus 5. There is no reason to change the sign because it's already x minus 5. This says we find that one denominator must be factored. Okay, we did that. And the signs must be changed in the other denominator. No, they don't, because it's already factored the right way. So we found a boo-boo in the book. Hello, we are so smart. All right, so what I'm going to do is I'm going to write the editor. And I'm going to tell them, hey, we found a boo-boo in the book. Now, there is a new book out, so maybe they found it and fixed it. That would be great. But I am going to send them an email. There's absolutely no reason to find a new, change the signs because the denominator here is the same as this. So that, yeah, this doesn't change at all from what's up here. So I bet what they meant, I bet this is a typo. I bet this is supposed to be a positive 5. I bet that's what happened. So what we're going to do is we're going to go back and we're going to redo all of this as if this were a positive 5. Let's just do that. Let's say positive 5. We'll change it and see if that's the same answer that's in the book, because what I came up with was not the right answer according to what they gave me. So if we do this, let's see if the answer that we get at the end matches, and if it is, then we know that they just made a typo right here. Okay. So let's begin again. We have x minus 3, but we already know what we need to factor to. It's going to be x minus 5, x plus 3, right? So if that is the case, then we do need to apply a -1 and a -1, right? So we're going to say minus x plus 2 over x, or this should be negative. This should be negative. What they did was, what it should have been here was 5 minus x. They typed it in the wrong order. That's what they did. Because then when you reverse it, you get negative x plus 5. And when you apply the negative, then you get x minus 5. And then that becomes correct. So that's what they did. They just typed it in the wrong order. It wasn't a typo with a plus or a minus sign. They should have done 5 minus x, and they did x minus 5. So that was on them. They goofed it. So let's see if we can get it right. X plus 3, x plus 3. So x minus 3 all over x minus 5, x plus 3, minus, and we have to do the whole thing, right? So this is going to be x squared. Let me draw my line here so it's not confusing. X squared plus 3x, 2x plus 6. And then this is going to be the same thing, x minus 5, x plus 3. All right, let's combine. We have x squared, and then we have a 1x here. Now this is going to change every sign here. So this becomes positive, this becomes negative, this becomes negative, this becomes negative, and this becomes negative, right? So now we have negative x squared, and we have positive 1x and a negative 3x. So that's going to be negative 2, negative 2. That's going to be negative 4x and negative 9. All over x minus 5. Actually, let's just do this. X squared minus 2x minus 15. So let's look at what the answer is that they have given us. And guess what? Let me pull it up. This one matches. Negative x squared minus 4x minus 9. So what they did right here was this should have been reversed. It should have been 5 minus x. So this was their typo that they had. Aren't you proud we found a typo in a math book? That is so smart of us. So that's how they got this. Because the other way, doing it the way they have written, is not the answer here. That we got something completely different, and we were correct. They reversed their numbers here. So good job, ladies and gentlemen, or actually just ladies, helping us find a boo-boo in the book. Y'all are so smart. All right, that's our final answer for this problem because we fixed their error. You know I'm going to be like proud of that for a week, right? So that's all I have for lesson 75, and I'll see you in lesson 76.